Hello, I'm Mr. Anthony Precella.
And I'm Timothy Precella.
And today in our college algebra class, we're going to be discussing square roots. This is sort of probably a review from other math classes you've taken, but it's the first day of the semester. Nothing wrong with having some review. When you click on that first assignment, you see over here, okay, Mr. Precella class lecture and Pearson class lecture.
Can you click on a problem? Show them what happens.
Over here's for the homework. You can't click on them. Okay? View the media files and questions listed below in the order listed. Questions that are not clickable will become available when you have viewed the required media. So
you're here, you're going to hear our lecture, and you're going to decide, oh, I don't need to watch this video.
But you still gotta click it.
Okay?
Oh my God.
Hello, this is Mr. Precella.
Oh, here, let's
That was made during the pandemic. And there he goes.
25 divides evenly into 50.
Everything I'm doing here, we're about to
The
do.
perfect square that divides
Okay,
into 50.
so anyway, this is,
That's
but you sure don't have to listen to it, but you gotta click on
Simplify
it.
the square root.
Okay? And then Pearson has some. Oh, this is Elaine Martin Gay, probably our favorite textbook author, doing a little video over square roots. You don't have to listen to it.
Just click it and get the
green
check. You see the
green check. Now you can start going through the homework. Okay? So, I guess I'm going to start.
You start.
Okay? Click on number 1. Okay. It says,
How do I increase the size?
let's see. How do we make this stuff bigger? Control plus. Oh, there. Okay. Do that.
Okay. There. Can y'all see the control? Hold on.
There. Can y'all see that? So,
Evaluate the square root of
this.
64.
Okay. Put it over here so I can write.
But what else? Oh, I got to switch, Toga.
Yeah.
Okay.
Just click
Is that
there.
it?
Okay. This symbol here is called a radical symbol or square root symbol. And problem number 1, you read that as square root of 64. Well, what does that mean? Well, it's asking you what number can you square or what number can you multiply by itself in order to get 64. Does someone want to tell me that? The square root is 8. Why? Because 8 times 8 is 64.
A number like 64 is called a perfect square. A perfect square is a number whose square root is just an integer.
Let's write out some perfect squares.
There are infinitely many
We
perfect
can't write all
squares,
of them, but
we'll
let's
find
write out the
some.
first 12. 1 times 1 is 1. I'm not going to bother writing that. 2 times 2, 4. 3 times 3, 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 49.
What's the next one? There's 64. What comes
What's
after
the next
that?
one I'm about to write? Does anyone want to say it? Y'all see where I'm getting? 7 times 7, 8 times 8. Yeah, 9 times 9. 10 times 10 is 100. 11 times 11. I'll keep going. 121.
12 times 12, we all know that. 144.
And I'll stop there. It goes on forever. But those are the perfect squares, the numbers whose square root you know. You don't need just from the multiplication tables. Now, what about,
I better punch in the answer.
Yeah, get over there and punch in our answers here. Right there.
Oh, here
Uh-huh.
and there. Okay. And so I'm going to type in the answer. I'm going to type in, what did we say that was?
8.
And then I can say check answer, or I could just hit enter.
Oh.
And if it's right, they'll give you a little word saying nice work. Now, if it's wrong, the next one will get wrong on the first time, so you can see what will happen. And so we'll say next question. We're going to go on to number 2.
Ooh.
256.
Ooh.
You'll want a calculator for number crunching.
Mm-hmm.
I think 256 is a perfect square.
Is 16 times 16 256?
Do we have a calculator? Let's see.
Well, I used to have a calculator on here, but they cleaned it off.
And our 2.5 year absence. Mm-hmm. Let's see. Wait.
It doesn't work.
We'll try this one. Try this one. Let's see.
Oh my gosh. Oh wow.
Oh my God. It has the last step you punched in there too.
Back in March 2020. This is really weird. Okay. So, I want to see what's the square root of
256. Is it a perfect
256?
square?
You see, there it is, 16. Now the natural question is, what would have happened if it had been a decimal number? Well, we don't like decimals in algebra. But let's go ahead. So we've already decided 16 is the answer.
Oh, let's punch in a wrong answer.
Yeah, go ahead
I'm going to punch in 15. What do you think?
and check the answer.
Oh,
They always give you some little hint that really helps, okay?
Yeah, that really
For a
helps.
non-negative number, b equals the square root of a such that b squared equals a. If that doesn't answer your question,
I don't know
I don't know what
does.
will. Okay? So go okay, and let's
okay.
try it again.
Let's try...
Change it to 14.
Let's try 14. You're right. Oh, he says try again.
Did I
They're
give
getting
you
a
the
little
hint?
annoyed at you. They repeat what they said, just louder, okay, I guess. They're waiting. You only get 3 shots. You get 3 shots to punch in the correct answer, and I'm going to put in the wrong one.
No, one.
Uh-oh, you see, that's incorrect. Now, you can go on to the next question, but then you're going to get that wrong. You should say similar question.
Oh.
324.
Pull up my calculator. Let's see.
Let's see, where's your calculator?
Right down here. Drag it up.
Oh, okay. And so, what did you say?
It's
18. I think that's right.
Sounds right.
So, the square root, we put 324. And sure enough, it's an 18. So now let's put in the 18. And
just get it right.
Yeah, I'm going to. Okay. Check. And well done. And now you've got that green check. Okay. Your goal should be to have a high homework average. I think, what is the prerequisites? 70, 80?
You
try to do better than
100.
70. Try for 100, okay?
Yeah. Oh, and notice what's happening right up here. It's updating your grade as it goes along. I had a student in an online class email me and say, how do I get this grade into Canvas? It'll sync naturally, okay? It might not sync immediately, okay?
But the MyLab gradebook is updating as you work a new problem. Right now, if you went to the gradebook on Pearson MyLab, they'd show you that you have a 10.89 for the first homework assignment. The more problems you work correctly, that grade will be going up.
Wow, now that we've really gotten started, we've done 2 of those 20 problems. I'm beginning to think we might get this done.
I think so too.
Okay, let's move on to number 3. And with number 3, we're going to answer the question, what do we do
Is 54 perfect
if
squares?
it's not one of those perfect squares?
Is 54 a perfect square? Let's look at that list of perfect squares again that Tony has written there. Oh, where is it?
Ooh.
Is 54 a perfect square?
They're just not talking
Say
to
no.
him. Oh, okay, good.
So, what's the the largest perfect square that divides evenly into 54? Start at 49 and go backwards. By dividing evenly, that means there's a remainder of 0.
We're going to rewrite 54
as one of these numbers
times another number.
What's the biggest number up here that divides evenly into 54? Notice we didn't write down 1 squared because 1 divides evenly into everything, okay? So the question
So here's, I'm going to show my thought. I'm going to use this calculator to show what I'm thinking. Okay, 54. I'll start with 49 and go backwards. Does 49 divide evenly into 54? And you might think, that idiot. Of course it doesn't. You know, it's a decimal number. I'm just showing my thoughts. But 36 doesn't either. 54 divided by 36, you see? What about
9?
okay, someone said 9. We can think of 54 as 9 times 6. Now follow the colors. If you can tell that there's a color, a green and a red. I think they come back automatically, maybe. Or maybe your eyes are just getting accustomed to it. I don't know.
Is that better? Yes. Okay.
9 is a perfect square. This green square root of 9, I could write as a green what? 3. Notice, I no longer need the green square root. Just like up here, when I wrote 8 and 16, I didn't put a square root. The square root symbol's gone. Now the 6, however,
stays under
the square root symbol. So 3 square root of 6
is the simplified answer for this square root that's not a perfect square.
Wait, sometimes I get questions by students. Wait, how do I type in a square root symbol? It's not showing it like it did during class. Well, wait, you got to click in the little square.
Click in that blue box, and now look at this toolbar they're giving you, okay? So you type your 3, and then, well, that's a fraction. That looks like a mixed number. What does that little hot button look like? An exponent, maybe? Okay, and
absolute values. If you find yourself using the absolute value bars,
I think you're doing something wrong. Hey,
there
look
it
at this. If you hover over it, use that bionic eye. What does that say?
Square root.
Square root. So you click that square root hot button, and what goes underneath it?
6.
Oh, I was waiting for them to answer it, Tony.
Okay, I'll be quiet. Okay, let's go to... Any questions on how we reduced that? This is...
Oh, and notice your grade's gone up. Now it's a 10.89%.
No, it was 10.89 a moment ago.
When I go next question.
Now
it's up to 15.84.
Yeah.
Okay.
Oh, gosh. Okay, so...
And I know you might be tempted, I only need a 70 to go on to the next assignment. Try
to, you know...
Uh-oh, square root of 24.
I've written it down, so let's switch it over.
Oh, yeah, forget. Is that a perfect square, 24?
So we look just at the number smaller than 24. 16, 9, 4.
What's the largest number there that divides evenly into 24? There's only one number there that divides evenly into 24 at all. So what is it?
4.
Okay, so it's a square root of 4. Times the square root of
another 6.
That's just a coincidence. That number under the radical isn't always going to be 6.
Yeah, don't decide the red number is always 6. No. So what green number?
Also realize that your problems are going to have different numbers from our problems. Your neighbor who you're sitting with, y'all can work on your homework together, but they're different problems.
Mm-hmm.
The answers will be different, okay?
The homework will have the same order. The tests are in a random order. So if you're working with a friend of yours on the homework, there'll be the same type of problems in the same order. But if you're working with a friend on your test, which you really shouldn't be doing, it's going to be a different order. It's going to be a mess. Your number 1 will not be the same type of problem as your friend's number 1, okay?
But for homework, go back to the square root of 4.
Yeah.
What are we going to do there?
A green 2.
And what are we going to do with that square root of 6?
Just write it down.
That's right. That's the simplified form. Is there any perfect square that will divide evenly into 6? Look at this list. Your final answer, the number under the radical, cannot be divisible by any other perfect square.
Mm-hmm.
For instance, you couldn't leave an 8 under a square root because 4 divides evenly into 8. The number under the radical cannot be divided by any perfect square other than 1, and 1
Which is why I did it right one. Let's see.
Any other questions there? Okay, y'all tell me. I'm going to type in the answer. What do I type first? 2, and then what do I do? That square root. This one right here? No, that's the nth root. That's for cube roots and fourth roots, okay? We're using square roots, and underneath it, another 6.
I mean, needless to say, I've lost my notes.
Oh, my goodness. Well, let's just go on to this
Yeah,
one.
go
How
on
you
to the
look
next
for
one.
Okay. Simplify the square root. Assume all the variables represent positive numbers. If the square root, there are no variables here, so if the square root is already simplified, state so. Why did they say so state? I would have said state so.
You're from Texas, Tim.
Okay. The square root of 43. Square root of 43. Okay. Those of you over there in the far off, y'all are seeing
grow
this?
as the semester progresses.
that
At least
side's
that's
gonna
what I
grow.
learned from my 3 months here in 2020. Let's go over here.
Oh, there we are.
Oh, well, actually, you've already written it down. I'm pulling up my calculator. And you might be thinking, oh, well, this, I can do this in my head. Do any of these numbers divide evenly with no remainder into 43? 43 divided by
Do any of those perfect squares?
36.
And once again, you're correct. 43 is a prime number. I think only 1 times 43 is the only thing that divides evenly into 43. And so this thing's already reduced.
Yeah.
The square root of 43 is just the square root of 43.
I wonder how we're going to enter that. Let's see, what do they want us to do?
There's a button. What are we going to select there?
Oh, you see it. Am I going to type in a number here, or what am I going to say? It's already simplified.
I wonder what would have happened if we had typed in a square root of, just typed in the same thing.
Oh, well, I don't know about that. Any questions?
Another square root of 24.
We've done that one, so you know what I'm going to do, and this is what I want y'all to do. If you come to a problem where you've already done that, you just type in the correct answer. Was it 2 square root of 6?
Yes.
And then, once it says check answer, instead of going on to the next question, I want you to exit out right here and say similar question. Now we'll do a new one. Okay, there. Square root of 98.
I don't think they're going to do that. I think they would just write the 2 square roots of 6. That's what I was going to do and go on. But
Oh, well.
okay, that's okay.
No, this is a better pen.
Oh, it is? Okay. The square root of, here's another one, another number 5. No, you said is it number 6? Oh, well, what happened to number 5?
We've already done 5.
Oh, yeah, okay, this is number 6, okay.
There.
And what was it?
Square root of 98.
Oh, is 98 a perfect square? Switch over so they can see my... There. There's my list of perfect squares. Is 98 a perfect square?
So let's think. Which one? Do you sort of have a feel for what number? Theoretically, only numbers
below 98.
could
So it has to be one of those.
81, 64, those are, I think, what about 49? But 98 divided by 49. Oops, wait, I got to click on my calculator. 98 divided by 49, I heard someone say 2, and that's right.
So you have a square root of 49 times the square root of 2.
In the 8th grade, our math teacher told us to put this little mark at the end of the square root
I
to
never
indicate
broke
it.
the habit.
I stopped that habit, as you can tell, because I was afraid it looks like a 49 to the first
Oh,
power.
you're right.
And so
I'm too old to change the habit.
Oh.
I close it down so you know that's where the radical ends.
But doesn't it sort of look like a...
49 to the first power, you're right. Okay.
Well, what's the green number? They want to get out early, Tim.
I know, so I'm going to have
Pick up What's the
pick
green
up the
number?
pace. What's the square root of 49?
Oh.
7. And what do I do with this stuff here? Just write it down.
Okay.
Good. And punching it
I
in.
type here 7 square root of 2. Enter. Next question. Oh,
Okay, keep going.
okay, it's another.
Now, if that happens to y'all, you can't do that. You got to punch in the answer, okay?
No, I'm punching it in.
Oh,
It's just okay. Oh, okay. Here's a good one.
Oh,
Square root of 640.
what number is this?
8.
Okay, the square root of 640. Uh-oh.
Okay. Is there a perfect square?
One of them might stand out. Which one?
Yeah, 64 times 10.
Right.
Okay.
Is it still raining? I'm not complaining. The drought's so bad that I'm not complaining about the rain. As I trudged through the parking lot, that's one of the things, that cancer medication made me, my bones are very brittle. I don't have osteoporosis, okay? But like my foot just slipped on May the 23rd. I just was walking on the sidewalk and I slipped a little. And I broke my ankle. I didn't even twist. I mean, it was just, I didn't fall or anything, but so walking across the parking lot, I was like, oh my God, I know I look like my 95-year-old mama when she's walking through a wet area, you know, but I'm waiting for y'all to tell me. What am I going to write here? 8 and, okay, that's right. Y'all are getting the hang of this. Okay.
8 square root of 10.
We're supposed to have a break at 3:20, but if we don't take that break, we can probably be through by 4.
Oh my gosh.
What is it?
Another square root of 24. We have no control over it. What am I going to type?
No.
2 square root of 6.
Of course, is that going to happen when y'all are doing the homework?
Oh,
Probably not.
Well,
Probably
I'm going
it'll
to
be
take a
different
similar
now.
question. One more. Okay, here's a good one. Square root of 72. This is number 9.
Okay. I can tell y'all are getting antsy. Y'all are ready to go.
Remember years ago, there's some assignments where we'll have, the ideal number is 15. I remember a student telling me once, oh, I can't learn math this way. In high school, we always had 100 problems. And I was like, but you can have 1,000,000. All you got to do is say similar question, okay? So if you're thinking, oh, I need more than 20 problems, do every problem twice. Then you'll have 40. Do every problem 3 times. You'll have 60 problems.
Okay.
Let's switch over and figure out, is there a perfect square that divides evenly into 32? Well,
And now I think it's 72.
I mean 72. Ooh.
What do y'all think?
Yeah.
So you're thinking of 30?
36.
You see, 9 will do it. 9 will do it, but then the problem is you would have an 8 under the radical. An 8 is divisible by 4. The number under the radical cannot be divisible by any perfect squares. So that's why we say you got to choose the biggest perfect square. 9 divides evenly, 9 times 8. But the biggest number here that divides evenly into 72 is 36. So we're thinking of that as 36 times 2. Oh, I got to stop that little hook, I guess. And what am I going to do here?
Green 6.
6. Okay.
They're getting impatient, Tim.
I can feel it.
6 square root of 2. Let me punch that in.
I should tell them the funny.
6.
That one day, right there before spring break, that last class meeting before spring break, I was finally back from MD Anderson, and I was in the class, okay? And Tony, back then it was an 8 till 11 class.
In the morning.
In the morning. And at about 10:15, Tony was up, and I was just standing around, you know, doing little things as I learned the way around the computer system. And Tony was like, well, okay, that's all I wanted to do. And I was like, wait a minute. We still have 35 minutes. We can do some more examples. I was having so much fun. I've been away from class for months, and I was just having so much fun. And I said, we can do more examples. And the class started laughing and putting their books away as I'm writing down the next problem. And I knew they were really, it was a great class, but I could tell. I think that they're mad at me. They're ready to go, and I was like, we'll just stay 15
I don't
more
know that
minutes.
they were mad at him, but I was mad at him. I was ready to start spring break. What about the square root of 44? 4 times 11. You see how clean it looks without that little hook 10? The square root of 4, 2, square root 11. So 2 square root of 11.
So 2 square root 11.
And my little watch says it's 3:18, and I've walked 5,616 steps today. We can stop and have a break, or we can keep going.
We should be through by 4. What do y'all want to do? Take a break? Now, if you need to go to the restroom, you do not need to ask permission. You
Just
stand
go.
up. There are 2 separate doors. There are projectors all around and stuff, and so if you need to excuse yourself, you go right ahead, okay? And so you don't need to apologize or ask permission or anything like that, right? So what do y'all want to do? Y'all want to take the 10-minute break or just keep going?
Personally, I'd rather get out at 4 because I haven't eaten today.
Oh, okay. That's one of those things.
Well, you know what, Tim? If you want to go take a break right now, you can watch the video tonight. It'll be on YouTube once this is over.
Are we going to embed it? We can't.
No,
because
no.
we've already.
Oh,
The new videos cannot be embedded back into the homework because as soon as it's clicked, okay, as soon as someone clicks on that homework assignment, and we've already clicked on it, you can't edit it. So what we'll do is we'll just be adding it to our YouTube video playlist, and we're starting a new one. What is it? Math 1314 class
Fall
lecture.
22.
Yeah, fall 2022.
Now move that little mouse.
Oh.
Okay, square root of 250. Maybe we put too many of these on here. I don't know.
Well, that's all we're doing in this assignment is square roots,
I
right,
know.
Tony?
Yeah. Okay, so how am I going to rewrite 250? Do I have a... Tim,
Oh, yeah, I got to switch. What's the largest perfect square?
What's the green number?
You can't see it.
Oh, yeah.
What's the largest perfect square?
25. So we'll go 25 times 10. The green 25 is a 5. The 10 just stays under there. Punch it in, Tim.
5 square root of 10. No, you know something? They're very. I think my math lab is very forgiving. They'll let you put it. Well, I'm not going to do that. I'm not going to get into that. I think let's just remember. They might allow you to put in the square root of 10 first times 5, but you have to make sure the 5 isn't under the square root.
Well, why would they want to do that? That's not how it's normally written. They're going to write 5 square root of 10.
Yeah, but I'm just saying. I think my lab will accept it if they put the 5 after it.
As long as it's not under the square root.
Yeah.
At this point, we're going to start multiplying square roots. Okay, so this is a different type of problem here. Number 12. The square root of 3 times the square root of 6. In order to multiply square roots, just multiply the numbers under the square root together. So the square root of 3 times the square root of 6 is the square root of 18. What did I do? I multiplied 3 times 6. And
Is 18 a perfect square?
just go. I wonder if you punch that in, square root of 18, what would Pearson say?
Let's see what they say.
Let's see. Punch in square root 18.
Square root of 18.
Oh,
They say the radicand.
Radicand.
The radicand is the thing that's under the radical.
The number under the square root symbol is called the radicand.
Oh, it can be factored using a perfect square factor. Remember I said there can't be any perfect squares that divide evenly into the number under the radical. And so 18, let's switch back. Where's Tony's little list?
Right.
No, okay, here it is. There. And move it down so they can
Yeah.
see.
Square root of 18. What perfect square divides evenly into 18? 9.
Okay.
So we will write that as square root of 9 times the square root of 2. Sometimes students tell me, oh, wow, do I have to do all that writing? I can get this done in fewer steps. And my answer is always, your goal and mine are different.
Your goal is to do the problems in as few steps as possible.
Get the correct
Our
answer
goal-
as quickly as possible.
Our goal is to explain our
Thought process. Okay? So 3 square root of 2 is what we will type in for that.
So
Delete that.
delete that. I have a 3 and a square root of 2. Any questions? No? Now, some of y'all I can't even see, so if you have a question, don't raise your hand, just call out. We're very
Those of you
important.
behind the wall, what, you may not realize, behind this thing, the big old thing right here, what are those called?
Pillars.
Those pillars weren't in the original design, architect designs that we saw. Okay? I was wondering what happened to change it.
Why did they decide that they needed those weight-bearing pillars like that throughout? I mean, they're the most, as you're walking around, it's a beautiful building, okay? I think it's beautiful, but it's beautiful. Oh, I know this answer.
And of course, here, they get the really big number, and I think it would have worked better without it.
Yeah.
The square root of 31 times the square root of 31. Let me clear my calculator, and let's multiply 31 times 31. 31.
No, it's not.
Oh, wait.
You gotta click again.
31 times 31 is 961. Okay. The natural question is, well, wait, can that be simplified?
Maybe, what do y'all think? Is that a perfect square? What times what will give you 961? 31. I think you've just now developed a property involving square roots.
Let me see.
9. The square root of x times the square root of x is equal to
X.
x.
You see, so
If
this
the
is
number under the square root is positive.
Because see why we're saying 31? Because 31 times 31 is 961. I'm wondering, go ahead and punch in 31 and so they'll feel more confident. Back in the olden days, before there were computers in the classroom, there were these paper books, and the answers were in the back of the book. Now remember, I'd work a problem from the book,
And then there'd be all the paper shuffling, all the students shuffling to see if he was right.
And then they'd feel relieved that I got it right, and it helped my confidence to know they believed me so much.
My students didn't do that.
Oh.
They trusted me.
Oh no, mine always. But I wonder.
Let's do a similar with it. Y'all tell me this answer. Y'all want to get out early, so what's this?
The square root of 19.
19,
Yeah.
that's right. You didn't have
And
to
I was going to say that I think it works easier if you just use smaller numbers to make sure you see the pattern. If I had, bring the coat down here. Suppose just use a small number like the square root of 5 times the square root of 5. In your mind, you know 5 times 5 is 25, so the square root of 25 is 5. Here's an important rule. It's going to follow us the rest of the semester. If you have two square roots
with non-negative numbers underneath the radical.
We'll discuss negative numbers under the radical, the square root symbol, the next time. But the square root of a times the square root of a.
A is any real number.
Yeah, it's just a. Okay, as long as the two numbers are the same. Now, I remember one semester the student said, well, wait, what if they're different? Well, you already know that. Look at number 12. If they were different numbers, you multiply them together and then simplify. Okay. Let's see, number 14.
That's not where I am. I'm here. Number 14.
Mm-hmm. Let's see.
The square root of 7 times the square root of 35.
Oh, I have a feeling I'll be glad we have a calculator for this.
Okay, let me switch back.
Okay, so let's punch in 7 times 35. Okay, so we have the square root of 245, is that right?
Let's see where the 245 came from. We multiplied the 7 by the 35.
Now let me flip back to look at my perfect squares.
Well,
oh gosh.
It has to be, it would be less than 120, okay? 140, you could start there, but I'm confident it can't be a number bigger than this 121. And 245 divided by 121, does that do it? 245 divided by 120. Is that an integer?
No. Okay, start.
It's a decimal number.
245 divided by 100. 245 divided by 81. And this is just my thought process I'm trying to show here. You might be thinking, I already know what it is. What about 49?
Look at that.
49 times 5. Okay. So I'm reducing the square root of 245. I'm thinking of it as 49 times 5. So that would reduce to...
The square root of 49 is?
7.
Okay.
Square root of 5, I know. Oh, no. So 7 square root of 5.
Any
And
questions?
I see some of y'all turning your heads and stuff. You can move those tables around.
I know.
Oh,
There's
I guess
wheels
y'all
on.
are young and you don't mind turning your head and stuff.
No, trust me, no.
Yeah.
No.
Get a certain age, you ain't going to want to be turning your head like that too much. Which is probably a bad thing. I bet you're supposed to turn your head.
That's something next.
Oh, at any time, you can stop by clicking that save button, or if you just X everything out, it saves it automatically.
As soon as you get the green check, they're raising your grade right there, okay?
Mm-hmm.
And we have it set up so that the grades will auto-sync with the Canvas gradebook. No, it's not instantaneous, okay? It's not like my math lab where the grade changes immediately. But it'll be synced eventually, and the grade will go to Canvas.
I already had to email a student that was asking me about it. So worried it wasn't syncing. I was like, give it time. Okay, so we've multiplied square roots. Now we're going to add and subtract them.
Adding and subtracting radicals is the same thing as combining like terms. You can't add something that has an x to something that has a y because they're not like terms. So to add or subtract radicals, you have to have like radical terms. That means you need to have the exact same thing under each square root. And in this case, yes, we do. We have the same number under each square root.
Okay, good.
Remind them of 9x plus 3x.
Yeah, 9x plus 3x. Do you remember way back in your first algebra class?
Oh, I forgot.
9x plus 3x. You would it's like adding 9 cats plus 3 cats is
12 cats.
12 cats. Sometimes people say x squared or cat squared. That doesn't make any sense. Okay, 9 cats plus 3 cats is 12 cats.
So you do the same thing here, which is going to give us a final answer of, you add the coefficients.
Add the 9 and the 3, the numbers that aren't under the square root. But do not add the numbers under the square root. Okay.
Just like x and x stayed in x, the square root of 3 and the square root of 3 stayed the square root of 3. Realize those square roots of 3 are not being multiplied. They're not being multiplied.
Yeah, we're now adding, not multiplying.
To add or subtract radical terms, you First of all, I have to make sure you have like radical terms. You can't add a square root of 3 to a square root of 5. But you keep the same radical part. You add or subtract their coefficients. Any questions there?
Oh, did you punch in that?
No, I have to punch it in. 12 square root of 3.
Notice how you have to click in that little box before it gives you the symbols.
Mm-hmm. Mm-hmm. Oh, next question.
You just hit enter twice.
I know.
Okay.
Are these like radical terms to add or subtract? You need like radical terms. What do y'all think? Are those like radical terms? Yes, they have the same thing under the
If
radical.
one of them had an x, we couldn't have done it.
Yes, if it was 9 square root of x plus 2 square roots of y, can't do anything.
But
So you keep the same radical. Oh, wait.
this is one you could probably do it without writing anything down. Okay, am I right? Could some of y'all have just typed in the answer? What would the answer be? Perfect.
Okay.
Perfect, perfect, perfect.
Okay, then I come back over here and I'll type in 11 square root of y. Any questions? Oh, here we're adding and subtracting.
Oh, let me write it down. 5 square root of 7 minus 3 square root of 7. Oh, plus 5 square root of 7.
Okay. Are these like radical terms? Yes. So
They all have the square root of 7. So we have 5 minus 3 plus
Which is?
5.
5 minus 3 is 2.
Plus 5 is 7. Is that what I heard a while ago?
Yes.
Oh, gosh. So notice, do not change the number under the square root symbol. That's the common mistake. No. So 7 square root of 7. After I just finished saying, do not change the number under the square root symbol, and we're going to do number 18.
What was the answer? Oh,
7
square root. I think I'm hearing rain.
Well, so what, Ken?
I know, that's what I was listening for.
Oh, okay.
Okay, I mean, that's when it's distracted.
Oh.
Wait a minute.
In
Are these
algebra.
like radical terms?
Oh, gosh.
They're
7.
not like radical terms.
And
But
now, there's
maybe-
not an option. If there were an A-B option for, they cannot be simplified. But there isn't. So that sort of hints.
You've got to be able to simplify this.
But you're thinking, oh my gosh, you said that they got to have the same thing under the square root symbols.
Okay. Well, 2, we know 2
We can't
be
simplify square root of 2.
reduced. What about that square root of 50 though?
Let's look at, see what I'm hinting at that we're going to do is what we were doing to begin with.
The
Let's
square
try to
root of 50.
simplify that square root of 50.
That's the largest perfect square that divides evenly into 50. And remember, if we're going to combine these, we better have what number left under the radical? 2. So 50 divided by 2 is 25, and sure enough, 25 is a perfect square.
So I am showing my thought process, just like I was doing over here. The way I'd write the green and the red, or Tim, you were using green and purple. Let's do the green and red with the 50, 25 times 2. So we have a black 7, that's this 7, I'm just carrying it down.
What's the square root of 25?
5.
So 7 times 5. What do we do with the square root of 2?
Just leave it there.
Okay.
So now, instead of 7 square root of 50, we've reduced this to 7 times 5. That's going to be, is that a 35? Square root of 2?
Any questions on our logic?
Y'all
This
follow
part
what I
right
did?
here is the important part. Any questions there? And we still have the minus 3 square roots of 2. Are they like radical terms now?
Yeah.
Yes. And so we keep the same radical part, add or subtract the coefficients. In this case, we're subtracting to give us
32 square root of 2. Any questions over that?
32 square root of 2. And remember, the toolbar does not show up until you click inside the blue box. And you laugh, but we'll get emails.
Oh.
The toolbar isn't showing up. You've got to click inside that blue box. Hey, look at this. Look
Okay,
at this.
the
Notice
last...
there's no
Yeah, there's no toolbar until you click up there.
once you click in it, that's when the toolbar shows
The last two problems deal with something called rationalizing a denominator. Rationalize a denominator. I'm writing one of my sentences. When the instructions say rationalize a denominator, that means rewrite the problem so that there is no fraction under a square root and no square root symbol in the bottom of a fraction. The bottom of the fraction is called what? Denominator? You're like, what the heck does that mean? Well, we'll show you what we're going to do on these. Okay? I'm not sure that we actually wind up rationalizing any denominators this semester other than right here, but we'll see. Let me write down this problem. Oh, wait.
I'm going to switch it back, but first,
Yeah, let them write it down. I'm right.
Okay, I'm going to switch
It's the
back.
square root of
13 over 5.
13 over 5?
Yes.
Okay.
Hold on. Let's see. The square root of 13 over 5.
So I've written it down. And here's how I'm going to go about this.
We don't want a fraction under a square root. We don't want a square root in the denominator. Okay?
When I see a fraction under a square root, this is what I normally think. Square root of 13 over the square root of 5. That's what that the fraction under this big square root symbol means.
That means they're taking the square root of the numerator and the square root of the denominator. Hey, we got rid of the fraction. The fraction's no longer under the square root.
But,
Now we have the square root in the denominator.
so how do we get rid of it? Well, it has something to do with the red rule that I stated right here.
Square root of any number times the square root of any number. You get rid of that radical.
I'm going to multiply this fraction by two square roots, a square root on top and on bottom. If I just want a 5 in the bottom instead of a square root of 5, I can multiply above and below by square root of 5.
The algebra for fractions, you know that you can multiply anything by 1 without changing the value.
And that's what the square root of 5 over the square root of 5 is.
Any number divided by any number is 1, so we're really just multiplying by 1. But
why did we do that? Well, do we have a square root now in the bottom? What's going to be right here where my pen is? Square root of 5 times the square root of 5 is 5.
We've gotten rid of the radical from the denominator.
But now, what about this 13 times 5? Well, multiply 13 times 5. What does that give us? 65. If you're not sure, just stick it into your calculator. Nothing wrong with that. 13 times 5, 65. And
Is 65 a perfect square?
let's see.
65 a perfect
No,
square?
64 is, but not 65. So just looking backwards from 64, do any of these numbers divide evenly into 65?
Say no.
So here's this is my thought process. 65 divided by, 36, no. 65 divided by 25, no. Well, I'm saying no because I'm getting decimal numbers. What about 16? No. 9?
Certainly not 4.
Well, you've already said certainly not 4, but I'm doing. So that 65 can't, square root of 65, we can't simplify. So in algebra, this fraction is the preferred way of writing that fraction. Instead of the square root of 13 over 5, it's better to write square root of 65 all over 5. If any of you are going to take trigonometry next semester, you're going to rationalize a lot of denominators. Are you going to do a lot of rationalizing in here?
No, not
I don't think so. Okay.
Oh, let's punch in the answer. Hey, this is exciting. We haven't punched
In a fraction.
So what do y'all think I should do?
How would I punch in that fraction? We'll start off.
If you start here, right
there.
here, look, when you click this, notice, use that bionic eye. It says fraction. There.
And up on top, put
What am I going to put here? A square root. That's right, a square root. And a 65. But now I need to get down to the denominator. Just click with your mouse. Or you could tab, but I never use that tab button.
and a 5.
Is that what I wanted to write?
Mm-hmm.
And realize there's a fraction here, a mixed number fraction. I have never, in all of my years, I've never used that mixed number fraction with an integer and a fraction.
Yeah.
Okay?
Algebra doesn't really lend itself well to mixed numbers.
numbers.
Okay?
Any questions?
That's called rationalizing the denominator. So basically, you multiply above and below by whatever's in the bottom of the fraction. If your friend comes up to you and says, how do I rationalize a denominator? You multiply above and below by whatever is in the bottom, the square root in the bottom. Hey, let's write that down. Multiply above and below by the square root in the bottom of the fraction.
To rationalize the denominator.
To rationalize the denominator, multiply above and below by the square root that is in the bottom of the fraction. And if we wanted to sound more fancy, instead of saying bottom of the fraction, I could have said denominator. And to illustrate that, that's problem 20. Mm-hmm. Oh, wow. Well, this is the last problem, so it's got to be the hardest, right? 21 square root of 5 all over 5 square root of 3. And I'm joking about that. Okay.
Oh, hey, look. We're already up to 95.05.
Oh, my gosh. Do you think we're going to make 100?
I think so.
Okay.
I think we're going to.
Oh, gosh. Okay. Switch the...
Oh, yeah.
Number 20 is designed to beautifully demonstrate what my sentence says right above there. To rationalize a denominator, multiply above and below, okay,
So we're going to multiply above and below by what?
the square root that's in the bottom of the fraction. Sometimes students want to multiply by this 5 too.
You can, but you're going to have more reduction.
Yeah, you're just going to get numbers bigger than you need. All you have to multiply by is the square root. So multiply above and below by the square root of 3. And now, well, on the top, we have the 21 there. So we just got to write that 21 down. But how do I multiply these square roots?
Square root of 5 times the square root of 3.
No,
Square root of
perfect.
15. That's right. You keep the same radical, you just multiply the radicands together. Now what about the square root of 3 times the square root of 3?
Yeah,
Just
okay.
3.
Well, I'm going to write down my black 5. I'm just carrying that over. And then the square root of 3 times the square root of 3. If you wanted to show the steps, it's the square root of 9, which is 3. So on this bottom, I have a little dot right there. That means times. So this isn't what I'm going to punch in. There's one more thing I need to do. What am I going to write on the bottom? What number? 15.
You're not through yet.
Oh my gosh, you're right. I'm not. Wow.
Let's look at the numbers. We have
What?
21 divided by 15.
Can I reduce? This is just like a normal reduction of fractions.
If you had 21 over 15,
How would you reduce just looking only at the numbers that aren't under the square root? What divides evenly into both of those? 3. So this 21 over 15, I can write as a, dividing by 3, would it be a 7 and a 5? And the square root of 15, can that be reduced? Is there a perfect square that divides evenly into 15? I sure don't think so.
I see you shaking your head no. There is not a perfect square that divides evenly into 15. So, this right here is your final answer.
Mm-hmm. So we have 7 square root of 15 all over 5.
Before we switch to enter this answer in, any questions on our logic? You multiply above and below by the radical, the square root in the denominator. The square root of 5 times the square root of 3 became a square root of 15. And you're just stuck with that. There's no perfect square that'll divide evenly. Square root of 3 times the square root of 3 became a 3 times 5 is 15. But then we had a common factor of 3 that we had to get rid of. Any questions there?
Let me go ahead and type it in. Or you type it in.
Okay, I'm going to let them tell me. Okay, I'm about to click in the blue box, and at that point my toolbar better show up. There it is. What am I going to click first? Fraction. What have we got on top?
Oh, 7 square root of 15.
7 square root of 15. What do I do to get down to the bottom? You
Just
click
click in
down
the-
the bottom.
Tim, that's not a hard
And
concept. 5.
see if they're paying attention.
Oh, okay.
And look at that. I say, okay, and look at that. Tony and I made 100 on the first homework
Oh, I'm
assignment.
so proud of myself. Yeah.
Almost, a lot of the times we won't be doing all the problems. We'll just be doing enough. Oh, I think this is all you need to get the idea. But for this first one, I think we did all of them.
Yeah.
Now, we need to discuss, let's see. Are there any questions? I'm going to stop recording, okay?
I'm going to click save. And, wait, goes back there. There's my now beautiful homework assignment. And I'm going to click stop recording right now. Oh, wow.